All right, everyone. Today we are looking at the sum and difference of cubes rule, and you can see that the rule itself is right here. Okay. Now that rule looks complicated because there's actually two sets of symbols in there. Okay. Rather than writing the rule with addition and writing the rule of subtraction, you can actually just write it all as one big rule using both the addition and subtraction symbols and kind of where they go. And we'll talk about how we use those. We do use it in a very similar way to the difference of squares, in that if we meet the criteria, we are allowed to use the rule, and then we just go ahead and apply the rule. Okay, so the two criteria that you need for using this sum and difference of cubes rule is the expression has to be a binomial. So it has to be two terms. Cubes rule does not work for trinomials or four-term polynomials or anything other than binomials. And everything has to be perfect cubes. That's it. Okay, there is not the subtraction requirement here, as you can kind of see next. If it's addition, you can use it, and if it's subtraction, you can use it. If it's addition, you're going to use the top symbols because we have the rule listed with the addition on top over on the left. And if it's subtraction, you're going to use the bottom symbols. Okay, so let me give you an example of exactly how we use this one. For the first one, it meets both of our criteria. 8x cubed is a perfect cube, and 1 is a perfect cube, and it's a binomial. Okay, so because it's subtraction, we're going to use the bottom symbols. So what our rule says in the subtraction situation is if we have two perfect cubes, it factors into a minus b, a squared plus ab plus b squared. Okay, so that's the rule we're using for this problem. So what we have to do is figure out what a and b are and then basically plop them in over here. Okay, this, what I just underlined, is supposed to represent the left side. Okay, it's the thing that we are factoring, and then the right side is what we're supposed to be factoring it to. To figure out a and b, you're basically taking the cube root. So you're basically figuring out what cubed gets you each of those things. So for example, 8x, I can break down into 2x times 2x times 2x. So 2x is going to be what my a is. And 1 I can break down into 1 times 1 times 1. So therefore b is 1. Okay. Sorry, that was a really terrible 2x. I had to go back and fix it. So 2x for a and 1 for b. Now I just plug those things over into the right-hand side, into my factored side. So I'm going to get 2x minus 1. And then for a squared, remember you're doing like a times a. So you're doing 2x times 2x, so that'd be 4x squared. And then ab is a times b, but b is 1, so that's just 2x. And then b squared is 1 times 1, so that's just 1. That's a pretty standard example for how you apply that rule. Now, if we look at the next one, we're basically going to be using the same rule except using the addition symbols. So a cubed plus b cubed will factor into a squared, a plus b, a squared minus ab plus b squared. Same thing as before. Both of these are perfect cubes, and I can see that because x to the 9th breaks down into x cubed times x cubed times x cubed, and 27y cubed breaks down into 3y, 3y, and 3y. So that means our a is x cubed, and our b is 3y. Okay, so now we're just going to plug into the formula, and we get x cubed plus 3y. That's just plugging in a and b. A squared means we're going to be doing x cubed times x cubed, so that's x to the 6th, minus ab, so we're doing 3y times x cubed, so that's 3x cubed y. And then 3y times 3y is 9y squared. Okay. What I'm going to have you guys do now is try both C and D. Remember to make sure to check to see if you can actually factor it or not first. Okay. So try C and D and then come back. Okay, for C, what you should have noticed is we have a 2x cubed here. So that is not a perfect cube because we can break down the x cube, but not with the 2. So this one's actually just prime. For D, both of these numbers are perfect cubes, so it's x, and 4 times 4 times 4 gets us 64. So we do have a perfect cube there. We're going to use the same rule that we just used right up here. I'm not going to bother recopying that. Okay, so the first parentheses is a plus b, so that's x plus 4. Second parentheses is a squared, so that's x squared, minus ab, so that's minus 4x, and then plus b squared, so that's plus 16. We'll look at more examples of cubes rule in class and talk about how you can make sure you differentiate those examples from squares rule and how you know when to use each rule.